Welcome to The Explainer. You know those scary-looking blocks of text that pop up right before an app crashes? Well, today we're going to pull back the curtain on what's really going on with program errors.
But hang on, let's start with a kind of mind-bending question. What if we've been looking at these things completely wrong? What if those so-called errors aren't actually errors at all?
What if they were actually part of the plan? It sounds crazy, right? But that's exactly the idea at the heart of modern, super resilient software. All right, let's get into it.
Okay, so to really appreciate why this is a game changer, we first have to talk about the problem itself. And the problem is that computer programs, at their core, they're surprisingly fragile.
Yeah, I'm sure you've seen something like this before. It's called a traceback. It looks like a total disaster, right? Like an accident report from a plane crash, pointing to the exact line of code where everything just blew up. And why do they blow up? Well, it's because programs have to follow rules, strict rules. They just can't do things that are logically impossible. You can't divide a number by 0, and you can't ask for the 8th cookie in a jar that only has 5. In the old days, if a programmer didn't think to check for every single one of these impossible situations, the whole thing would just freeze up. Game over.
So, how on earth do you build software that doesn't just shatter into a million pieces the second something unexpected happens? Well, you build in a safety net. The goal isn't to stop the fall, it's to have a way to catch it gracefully.
And this idea represents a huge shift in thinking. The old way was called look before you leap. It was super cautious. You check everything before you did anything. It was slow, and you had to be a fortune teller predicting every possible problem. The new way is way cooler. It's called ask forgiveness, not permission. You just go for it, try the action, and if a problem pops up, then you deal with it. It's way more optimistic and makes the code so much cleaner.
So, what's the magic tool that lets us do this? It's something called an exception. You can think of it as a formal SOS signal. When something weird happens, the program doesn't just crash and burn. Instead, it creates this little object, this exception, that holds all the information about what went wrong. It's the foundation of this whole emergency response system.
Okay, so we have this emergency response system. How does it actually work? Let's break it down.
It's a really neat three-step process. First, you take the code that might be a little risky and you wrap it in what's called a try block. That's step 1, the monitored zone. Now, if something goes wrong inside that zone, the system immediately pulls the fire alarm. That's step 2, it raises an exception. And once that alarm goes off, it triggers step 3, the emergency plan, which is all the code you've written in an except block to handle that specific alarm.
And these alarms are super specific. For example, if your code tries to do that impossible math problem of dividing by 0, the alarm that sounds is a 0 division error. It's not just a generic error. It's telling you exactly what's up. Or say you try to grab an item from a list that isn't there, like looking for floor 13 in a 12-story building. The alarm for that is an index error. Again, very specific.
And what if you try to do something that just doesn't make sense, like adding the number 5 to the word hello? Well, you'll get a type error. Each alarm has its own name and purpose, which lets the program respond in a really smart way.
But wait, there's more. This isn't just about catching basic problems. The system gets really powerful when you start building more detailed response plans and even creating your own custom alarms.
So you can add another piece to this puzzle called an else block. This is code that runs only if everything in the try block went perfectly smoothly, with no alarms at all. It's like a little all clear signal. And then there's the finally block. This guy is the ultimate cleanup crew. The code in finally runs no matter what. Whether things succeeded or an alarm went off, this code always runs. It's absolutely perfect for things you have to do, like closing a database connection or releasing a file.
Now, this is really cool. These exceptions aren't just a random pile of alarms. They're actually organized in a hierarchy, kind of like a family tree. So you have these very specific errors, like a type error, but they all belong to a bigger family, like the general exception class. Why does this matter? Well, it means you can write code to catch one super specific problem, or you can cast a wider net and catch any problem from an entire branch of the family. It's incredibly flexible.
And this is where it gets really creative. You're not limited to the alarms that come built in. You can make your own. Take a look at this code. For a banking app, a developer could invent a brand new exception called invalid withdrawal. So now, if a user tries to take out more money than they have, the program doesn't just have a generic meltdown. It raises this very specific custom alarm that can carry all the crucial info like, hey, the balance was $50 and they tried to take out $100. It makes handling these situations so much more precise.
Okay, so here's the big takeaway. Exceptions aren't just for disasters. They're not just about preventing crashes. When you use them cleverly, they can be an amazing tool for just controlling the flow of your program.
Think about it. Let's say you're building an e-commerce site. Is an item being out of stock really a system crashing error? Of course not. It's a totally normal, predictable event in the life of a store.
And this is a perfect example of using exceptions for what we call flow control. Instead of writing code that says, first, check if the item is in stock. If it is, then sell it. You just try to sell it. If it works, great. If it's out of stock, the system raises a nice, clean, out-of-stock exception. You see how that separates the normal, happy path from the alternative out-of-stock path? That is asking for forgiveness, not permission in its purest form. It makes your main logic so much easier to read because it's not cluttered with all these what-if checks.
So let's bring this all home. The next time you're using an app and you see an error message pop up, I want you to see it differently. Don't just see a crash or a failure. See it for what it really is. A sign that a well-designed system is talking to itself, managing the unexpected, and keeping the whole show running. It's not a monologue of failure, it's a conversation.